Hi friends, this is Rashekar, a GET faculty for electrical machines. Today in this video, we are going to discuss about equivalent circuit of our transformer. In generally, our transformer circuit, for example, see here, I am taking our transformer. See here, this is my transformer, for example. Of course, our transformer having windings, and this is in secondary winding having some resistance and some reactance, and here load, and here load, and here load, and primary winding even having some resistance and inductor we saw up to now, and here supply voltage, this is R1, X1, R2, X2, induced EMF E2, induced EMF E1, here the current flowing through the winding I1, and here the current flowing through the winding I2, etc. This is actually our transformer. Its circuits are in generally R1, X1 in the primary, and here we have a core. This is a core equivalent circuit we saw already. And primary EMF represented here. For example, this is the primary EMF E1. And next on secondary, this is secondary induced EMF E2, and of course R2 and X2. This is actually the transformer circuit. Here the supply voltage V1 and here the load voltage V2. This is the transformer circuit. But we want equivalent circuit of our transformer. So what is equivalent circuit means? Here the secondary parameters either transferred into the primary, or the primary parameters transferred into the secondary. Then the resultant circuit is called equivalent circuit. What I am saying that the secondary parameters are transferred to the primary, or the primary parameters are transferred to the secondary. Sir, why we have to transfer those parameters? For easy calculations, for easy analysis, just for easy analysis, we are going to transfer the secondary parameters into the primary or primary parameters into the secondary. The resultant circuitry is called equivalent circuit. Let's see, for example, I am drawing the equivalent circuit with referred to, or with respect to, with referred to primary, equivalent circuit with referred to primary means the secondary parameters transferred into the primary. With referred to primary means the secondary parameters transferred into the primary. For example, with referred to secondary, means the primary parameters transferred into the secondary. Now, I am going to draw the equivalent circuit with respect to primary. Let's see how it is. With respect to primary, let's see how it is. Let's see how the equivalent circuit is. See, I am drawing the final equivalent circuit. In approximation, the no load component brings forward because at no load condition the leakage flux is very less. At no load condition the current also very less. No load current just 2 to 6%. That's why I'm taking approximation. The no load branch is as forward. Here the current is I naught, and here the current is I1, because in the primary here the resistance is R1 and reactance is X1. Of course, you know that this is R0 and this is X0. What is the current flowing in this branch? Working current. And the current flowing in this branch, magnetizing current, you know that. This is a primary one. What we have next? We have a secondary one. Where is the secondary? Here the secondary resistance and reactance. Resistance is R2, reactance is X2, like this in secondary. The secondary parameters transferred into the primary, then only it is called with respect to primary. So I am transferring the secondary parameters. What is there here? Here the current is there, that is I2. Of course here EMF is there, E2, everything. So now I am transferring the secondary parameters into the primary. Nothing but the secondary circuit is combined with primary. This is transferring the secondary parameters into the primary. Now this resistance is called R2 dash. This reactance is called X2 dash. This current is called I2 dash. Because we know I1 is equals to I0 plus I2 dash. I1 is equals to I0 plus I2 dash. I0 plus I2 dash. This is the equivalent circuit of my transformer with respect to primary. With respect to primary. But here some different words are there. Unknown words. What are the unknown words? One is the I2 dash and other one is the R2 dash and other one is the X2 dash. If R2 dash, X2 dash is there, automatically Z2 dash also is there. Of course, E2 dash also is there. I said you, E2 dash also is there. Actually here E1, here E2. The E2 is transferred into the primary. E2 is transferred into the primary. Now these are the different parameters. See, actually here E1, here E2, the E2 is transferred into the primary. That is called E2 dash. So we can written as this E1 is equals to E2 dash. E1 is equals to E2 dash. This E2 dash is equals to E2 by K. E2 by K. We know that E2 by E1 is equals to K. E2 by E1 is equals to K. E2 by E1 is equals to K. So E2 dash is equals to E2 upon K. One word. And another word also well known, I2 dash. I calculated when transformer at loaded condition. The load component of primary current is equals to some K into I2. Some K into I2. This is already calculated. And this is also very easy formula. You can remember these two, I2 dash and E2 dash completed. I2 dash and E2 dash completed. Now R2 dash, X2 dash, I2 dash, Z2 dash. How we can calculate R2 dash? Here one assumption, the copper losses before transformation is equals to copper losses after transformation with same resistance, not other resistances, with same resistance. Copper losses before transformation is equals to after transformation. Which is the transformation branch, primary or secondary? Secondary is the transformation branch. What are the copper losses in the secondary before transformation? Before transformation, the copper losses in the secondary is I2 square R2. I2 square R2 is the copper losses before transformation. But when it is transferred to the primary, nothing but we have to take here the current. Which current? Here we have to take I1 square because that is transferred into the primary. So I1 square into what is that resistance? R2 dash. That is transferred into the primary. That's why I1 square into R2 dash. Now calculate the R2 dash. I want R2 dash. R2 dash is equals to R2 into I2 upon I1 whole square. So tell me what is the answer? R2 into I2 by I1. I2 by I1 nothing but K or 1 by K. So it is not K, sir. K is equal to I1 by I2. But here I2 by I1 nothing but 1 by K, nothing but 1 by K square. So what is R2 dash? R2 dash is equals to R2 by K square. R2 dash is equals to R2 by K square. Very, very important. Next one, X2 dash. For this, per unit reactance before transformation is equals to per unit reactance after transformation. Per unit reactance before transformation is equals to per unit reactance after transformation. Generally, reactance nothing but X2. Reactance drop nothing but I2X2. Reactance nothing but X2. Reactance drop nothing but I2X2. Sir, I want per unit reactance. Per unit value is equals to actual value by base value. What is the base value for secondary? Base value for secondary is E2. Base value for secondary is E2. So the per unit reactance before transformation is secondary I2X2 upon E2. What about after? After nothing but we have to take I1. But here after transformation this is X2 dash. What is the base value for primary? Base voltage for primary is E1. Now if you calculate X2 dash is equals to E1 upon E2, I2 upon I1 multiplied with X2. Now tell me what is the answer? E1 by E2 nothing but 1 by K and 1 by K, 1 by K, 1 by K, 1 by K square. So X2 by K square. X2 dash is equals to X2 by K square. X2 by K square. very important, R2 dash is equal to R2 by K square, X2 dash is equals to X2 by K square. And next Z2 dash, we know directly Z2 dash is equals to Z2 by K square, Z2 dash is equals to Z2 by K square as usually, because Z2 dash is similar to X2 dash. Per unit impedance before transformation is equals to per unit impedance after transformation. Everything is same. So here the new words and very important words are these. I have to remember these words for problems. So I2 dash, E2 dash, R2 dash, X2 dash, Z2 dash. And its calculations also I given you. Now see here. Finally, what is the total resistance in the circuit? The total resistance in the circuit is R1 and R2 dash. What is the total reactance in the circuit? X1 and X2 dash, Z1 and Z2 dash. This R1 plus R2 dash is called equivalent resistance. Equivalent resistance, this is represented by R01. This is represented by R01. R01 nothing but the equivalent resistance with referred to primary. With referred to primary. Here X01 nothing but the reactance referred to primary. And Z1 plus Z2 dash is nothing but Z01 with referred to primary. Z01 and X01 and R01, this is also important. You have to remember. One represents with referred to primary. One represents with referred to primary. This is what completely the equivalent circuit with referred to primary or with respect to primary. With respect to primary. For example, if they ask you the equivalent circuit with referred to secondary, the equivalent circuit with referred to secondary, then what are the new things here? When with referred to secondary, the current is called I1 dash and the voltage is called E1 dash and the resistance is called R1 dash, X1 dash, Z1 dash. R1 dash, X1 dash, Z1 dash. Now tell me, what are the parameters? Tell me, sir, what are the answers? Simply very reverse to this one. Here I2 dash is equal to K into I2, but here I1 dash is equals to I1 by K. E1 dash, here E2 dash is equals to E2 by K, where E1 dash is equals to E2, E1 dash is equals to E2, that is equals to E1 into K, E1 multiplied with K, E1 multiplied with K. This is what E1 dash. What about R1 dash? We have to calculate again the copper losses before transformation is equals to copper losses after transformation. Before transformation nothing but primary circuit. After transformation nothing but secondary, but the resistance is same. So from this R1 dash is equals to I1 upon I2 whole square into R1. What is I1 by I2? I1 by I2 is nothing but K, right? So R1 dash is equals to K square into R1. Similarly, X1 dash is equals to K square into X1. Similarly, Z1 dash is equals to K square into Z1. K square into Z1. Now, what is the total resistance? The total resistance is R1 dash plus R2. R1 dash plus R2 can be written as R02. R02, 02, the 2 represents with respect to secondary. With respect to secondary. Here, R02 is called equivalent resistance. Equivalent resistance with referred to secondary. Equivalent resistance with referred to secondary. As usually, x1 dash plus x2 is equals to x02. As usually, z1 dash plus z2 is equals to z02. Like this. This is the parameters with referred to secondary. I am not given the circuit, but just the parameters are important for problems, numericals, right? This is the equivalent circuit with referred to secondary, equivalent circuit with referred to primary, with referred to primary. These are the different derivations, very important for numericals. Are you okay? Right? Thank you.